The second topic in this chapter is electric field. Electric field is a vector quantity. One useful way of visually representing the vector nature of an electric field is through the use of electric field lines of force. Electric field lines are simply lines of electrostatic force. The pattern of lines point in the direction that a positive test charge would move if placed upon the line. This pattern of lines point in the direction that a positive test charge would move if placed upon the line. If a positive test charge is placed near the positive charge, the test charge will move away from the positive charge. As such, the electric field lines are directed away from positive charge sources. If a positive test charge is placed near the negative charge, the test charge will move towards the negative charge. As such, the electric field lines are directed towards the negatively charged sources. The direction of the field is communicated through the arrowhead that points in the appropriate direction on each line. This is how the electric field pattern looks like for a positive charge. You will notice that the electric field lines point radially outwards from the positive charge. If you look carefully, you will also see a little arrow on top of the letter E. This arrow tells us that electric field is a vector quantity. There are some rules we have to follow when drawing electric field patterns. Number 1. Electric field lines always extend from a positively charged object to a negatively charged object, or from a positively charged object to infinity, or from infinity to a negatively charged object. Number 2. Electric field lines never cross each other. 3. The density of the field lines indicates the strength of the electric field. Electric field lines are most dense around objects with the greatest amount of charge. Number 4. Where electric field lines meet the surface of an object, the lines are perpendicular to the surface. Since electric field is a vector, in order for us to determine the electric field line patterns for a configuration of charges, it is necessary to find the resultant electric field vector at each location so as to obtain the resultant of the field patterns for the individual charges within the configuration. For a region of space with two positive charges, charge A and charge B, each charge creates its own electric field. The blue arrows are the electric field vectors due to charge A, whereas the green arrows are the electric field vectors due to charge B. The magnitude and direction of the electric field at each location is simply the vector sum of the electric field vectors for each individual charge. The red arrows gives you the resultant electric field vectors at the different locations due to charges A and B. If we repeat the above procedure for a few more locations, we would be able to find the electric field pattern for this configuration of two positive charges. Notice that the resultant electric field vectors point tangentially to the direction of the electric field lines at any given point.